Physics 9702, Paper 12, that is MCQ Paper 1, second variant, October-November 2015. Part 1. Question 1. Which list shows increasing lengths from beginning to end? Now the length is given in meter, but they have given many prefix. We have to get it in ascending order. 1 nm, that is 1 nanometer, is equal to 10 to the power minus 9 meter. 1 micrometer is 10 to the power minus 6 meter. 1 millimeter is 10 to the power minus 3 meter. 1 centimeter is equal to 10 to the power minus 2 meter. If we write it in ascending order, we'll get 1 nanometer to be the least, then goes up to 1 micrometer, then 1 millimeter and reaches the maximum at 1 centimeter. Let's check our option A. 1 centimeter. That means it's starting with the highest value, then it decreases to 1 nanometer. So it's not in ascending order. So option A is incorrect. Option B starts with 1 micrometer, that's here. Then it goes up to 1 millimeter. That's here, which is right. Then it comes down to 1 nanometer. So it comes back to 1 nanometer. So it's not in ascending order. Option C, 1 nanometer. That's right. Then goes to 1 micrometer. That's correct. Then goes up to 1 millimeter and then 1 centimeter. So it is in perfect ascending order. Therefore, the answer is option C. Question 2. Which equation contains only scalar quantity? What is scalar quantities? These are quantities that are described only by a magnitude. We do not consider the direction of action. So let's check A part. Acceleration is given force over mass. Mass is a scalar quantity, but force, we consider the direction as well as magnitude. So this is not a scalar quantity. So option A is not the answer. Option B, power, is equal to work over time. Work is a scalar quantity. Time is as well a scalar quantity. Many students get confused with the fact that work is a vector quantity, which is completely wrong. The confusion comes because work is the outcome of the force and displacement caused by the body. That means work is the product of the force and displacement. But it's not just the product, it's a dot product. Dot product means if you take the product of two vectors, then dot product will give you a scalar quantity. In short, you have two products. You can take it as dot product as well as cross product. If you take two vector quantities in dot product, you will get a scalar value. If you take cross product of two vectors, then you will get vector. So here we are taking dot product, so which is equal to W, that is the work, is equal to Fs cos theta. F is the force, S is the displacement, theta is the angle between the force and the displacement. Force and displacement are vector quantities. They both have magnitude and direction. And the dot product of two vector quantities always give a scalar quantity. So work has only magnitude but not direction. So remember, when we take dot product of two vectors, we will get a scalar quantity. That's why the product of the force and the displacement gives us work, which is a scalar quantity. So the option B should be right. Let's check option C. Again, there is a force, which is a vector quantity. So the option C is not the answer. Option D, Displacement. Displacement is a vector quantity which we consider the magnitude as well as the direction. So D is not the option. Therefore, the answer is B. Question 3. The time t taken for a satellite to orbit the Earth on a circular path is given by the equation t square is equal to k into r to the power cube over m. So t is the time period, r is the radius of the orbit, m is the mass of the Earth, k is a constant. What is the SI base unit of k? When we have to find the SI base unit of k, the first thing that we have to make is make k as the subject. So I'm taking my k to the left side and taking the other terms to my right hand side. So if I want to take my k to the left hand side, I take the remaining term, that is mt square over r cube, to one side. The SI base unit of t is second. That is why second to the power square. I'm getting second to the power square. The SI unit of mass is kg. SI unit of the radius is meter. So r cube, I'm substituting meter cube. Now get all these answers in your numerator. So s cube, m to the power cube, from the denominator when it goes up, it becomes m to the power minus 3. And this is kg. So the answer for the k, that is the SI base unit of k, is kg, meter to the power minus 3 second square. As you can see, the answer is option C. Question 4. Which row gives reasonable estimate for the mass and the speed of an adult running? So 10 to the power 0, that's mass. So 10 to the power 0. Anything to the power 0 is 1. So 6 into 1 will give you 6 kg. That is not the weight of an adult. It may be probably the weight of a toddler. So option A is not the answer. 10 to the power 1 is 10. So 6 into 10 is 60. That could be the average mass of an adult. So this could be the answer, any one of them. 6 into 10 to the power 2. 10 to the power 2 means 100. So 6 into 100, 600. So that's not a possible mass of an adult. So now we have filtered our answer to B or C. Now we have to cancel one out. Let's check the speed. 10 to the power 0 is 1. So 5 meter per second and 50 meter per second. It's not possible to run at 50 meter per second. This could be the speed of a motorbike. So we could run at the speed of 5 meter per second. So this is a reasonable estimate. So the option is B. So C is not the answer. So the answer is B. Question 5. A student measures the time t for one oscillation of pendulum of length L. Her results are shown in the table. This is the length of the pendulum. This is the time period of the oscillation. As you can see, they have given with uncertainty. She uses the formula t is equal to 2 pi root L over g to calculate the acceleration of free fall g. What is the best estimate of the percentage uncertainty in the value of g? Now we get to find the percentage uncertainty of g. First thing we have to do is make g as the subject. So what I can do is I can square this term. So when I square this term, I get t square is equal to 4 pi square L over g. Then I can take this g to the left side, take this t squared to the right side. So I'll get my g as g is equal to 4 pi square L over t square. Now this equation is a combination of multiplication and division. Remember one thing, when we have to calculate for the percentage uncertainty, when it is multiplication or division, we have to take the sum of the fractional uncertainty. So fractional uncertainty means for L, the fractional uncertainty is dou L over L. The fractional uncertainty for T is dou T over T. Now for G, the fractional uncertainty is dou G over G, but we need percentage uncertainty. So I'm multiplying the fractional uncertainty by 100, which is equal to, this is a numerical value, so uncertainty is not possible. So just omit that part. For L, you have uncertainty. So fractional uncertainty is dou L over L. To get the percentage uncertainty, I'm multiplying by 100% plus there is a square. That means there is a power for t. So that power should be multiplied. So I'm getting 2 into del t over t. That's the fractional uncertainty of time period. Into 100 will give me the percentage uncertainty. Now substitute these values. For dou L, I have 0.001 divided by L value is 0.420 into 100 plus 2. For dou T, I have 0.1 divided by, for T, I have 1.3 into 100. When I simplify my answer, I'm getting close to 16%, which is option D. So 16% is my percentage uncertainty. The diagram shows two complete pulses on the screen of cathode ray oscilloscope. A grid of 1 centimeter squares covers the screen. The time-based setting is 1 microsecond per centimeter. How long does each pulse last? Remember, this is the screen of the cathode ray oscilloscope. They have given the time-based setting as 1 microsecond per centimeter. That means 1 centimeter corresponds to 1 microsecond. How long does each pulse last? This pulse lasted for 2 divisions, which means 2 divisions. It's lasting for 2 division. So if I know 1 centimeter corresponds to 1 microsecond, 2 centimeter will correspond to 2 into 1 microsecond per centimeter. My answer is 2 microsecond. That means the time period for the pulse to last is 2 microsecond. As you can see, that is option A. Question 7. A boy throws a ball vertically upwards. It rises to a maximum height where it is momentarily at rest and then falls back to his hands. Which rho gives the acceleration of the ball at various stages in its motion? Take vertically upwards as positive, ignore air resistance. So when a ball is thrown upwards, what's the acceleration? And at maximum height, it's at momentarily at rest, what's the acceleration? While it's falling, what's the acceleration? This is the question. They asked us to ignore air resistance. The acceleration due to gravity is always a constant value and it is always negative. We all know the value of it is minus 9.81 meter per second square. The acceleration is negative when going up because the speed is decreasing. When you throw a ball upwards, you're throwing with maximum speed. Till it reaches the maximum height, the velocity will decrease. And at maximum height, it will be zero, which means it is momentarily at rest. So the speed is decreasing when it moves upwards. As a result, we are taking our acceleration to be negative, which is minus 9.81 meter per second square. This is why rising. Since this is positive, these are not the answer. Now, the acceleration is negative when going down because it is moving in the negative direction. Even at the top of the path, where the instantaneous speed is 0 meter per second, the acceleration is still minus 9.81 meter per second square. So throughout, our acceleration is going to remain the same. For example, if you're throwing a ball upwards, it's this acceleration which causes the speed minus 9.81 meters, which makes the speed goes to 0 at maximum height. It doesn't mean it doesn't have any acceleration. If it doesn't have any acceleration, it will stand still there, it will not return back. But this is returning back because of this acceleration. So throughout the journey, whether it is going up, staying at the maximum height, which is momentarily at rest, or falling back, it's going to have the constant negative acceleration, which is minus 9.81 meter per second. As you can see, the answer is C. Sorry, the answer is B. Question 8. The curved line PQR is the velocity time graph for a car starting from rest. So you have a graph, y-axis corresponds to velocity, the x-axis corresponds to time. What is the average acceleration of the car over the first 5 seconds? So they're not asking you any acceleration, particularly they mentioned average acceleration. Let's see what's our option A, the area. They're talking about area. If you take the velocity time graph's area, you will get displacement. So if you're taking the option A, the area below the curve PQ, that's going to give you the displacement. If you're taking the area of the triangle PQS, that's going to give you approximate displacement. If you're taking the gradient of the straight line PQ, that will give you the average acceleration. That is, the gradient of a VT graph will give you acceleration. If you're going to get the gradient of the tangent at Q, you're going to get instantaneous acceleration. Since the question says average acceleration, we need to get the gradient of the straight line PQ. Therefore, the option is C. Question 9. A ball is released from rest above the horizontal surface. It strikes the surface and bounces several times. The velocity time graph for the first 2 bounces is shown. What is the maximum height of the ball after the first bounce? So they are throwing the ball from a maximum height. It falls to the ground, it bounces back and it reaches another maximum height. Then again it falls back. So now they are asking you the maximum height it reaches in its first bounce. So when it is falling with maximum height, the velocity is going to be 0. So at first they are starting to throw from maximum height. So this is the position where it is falling because the velocity is 0 at maximum height. When it hit the ground, it's going to have maximum velocity. So this is the place because it has the maximum velocity. This is the place where it gets hit. And when it bounces back, it's going to move in the opposite direction. So the velocity will be reversed. So there will be a negative velocity just to show the motion now is opposite to the previous motion. So now there is 2 meters per second, but it's bouncing in the opposite direction. So the velocity is -2. So this is the place it's bouncing. Then it reaches a maximum height. When it reaches a maximum height, again the velocity will be 0. And then it comes down, again it hits the floor. But we need to know the maximum height of the ball after the first bounce. This is a velocity time graph. If you get the area of the velocity time graph, you will be getting the displacement. So in this case, from the bouncing to the part it reached the maximum height, this shaded region corresponds to the height reached after bouncing. So this is an area of a triangle. Take half into base into height. Half into base 0.30 to 0.50. So the difference is 0.20 and the height is 2, so 2.00. So area of the shaded region is going to be 0.20 meter. As you can see, that's option A. Question 10. A bus takes a time of 25 seconds to reach a constant speed while traveling in a straight line. A graph of speed v against time is shown. So this is the velocity over time taken by a bus for 25 seconds. Which graph shows the variation with time t of the resultant force F on the bus? According to the Newton's second law, we know that force is equal to ma, which means force is directly proportional to acceleration. So this graph, the force over t and the acceleration over t graph will have the same shape. The gradient of vt graph will correspond to acceleration, which is of the same shape of the force. As you can see from this term to this term, it's a straight line, which means the gradient is constant. When the gradient is constant, it means the acceleration is constant. So acceleration is constant means the resultant force is going to be constant. It's going to have one value. So as you can see here, this is constant for some time. Other graphs corresponds different shape but does not give the constant for the first approximate 6 seconds. So the answer should be A, but let's look into some explanation. So constant force for 0 to 5 I have taken, but it's something like 6 or 7 seconds. But the next, again up to somewhere around 15 seconds, it's again a straight line, a little less than 15 seconds, again straight line, but the gradient is steeper. That means it's a constant value, but gradient is steeper than the previous one. That means acceleration is greater than the previous gradient, previous acceleration, which means the resultant force is also constant, but with a greater magnitude of the previous one. So as you can see, this one is a constant value which is higher than the previous force. Then the next diagram implies the value, the decreasing gradient. The gradient is decreasing, which means acceleration is decreasing. In other words, the force is decreasing. As you can see, it's decreasing. So the answer is option A.